Imagine a giant, drum-shaped antenna reflector, spanning an impressive 39 feet in diameter, unfolding like an umbrella in space. This marvel of engineering is part of the NASA-ISRO Synthetic Aperture Radar (NISAR) satellite mission, a collaborative effort between NASA and the Indian Space Research Organization, ISRO. The successful deployment of this massive reflector marks a significant milestone in the capabilities of the satellite, which will track the motion of ice sheets and glaciers, the deformation of land due to earthquakes, volcanoes, and landslides, and changes in forest and wetland ecosystems with unprecedented precision. But here's where it gets fascinating. The NISAR satellite will aid decision-makers in fields as diverse as disaster response, infrastructure monitoring, and agriculture, making it a game-changer for global communities and stakeholders. The satellite's radar antenna reflector, which had been stowed away until the 30-foot boom that supports it could be deployed and locked in place, is now fully extended, ready to direct microwave pulses towards Earth and receive the return signals. This is the largest antenna reflector ever deployed for a NASA mission, and its successful deployment is a testament to the ingenuity and expertise of the mission team. As Karen St. Germain, director of the Earth Science Division at NASA headquarters in Washington, noted, the successful deployment of NISAR's reflector marks a significant milestone in the capabilities of the satellite. From innovative technology to research and modeling to delivering science to help inform decisions, the data NISAR is poised to gather will have a major impact on how global communities and stakeholders improve infrastructure, prepare for and recover from natural disasters, and maintain food security. The NISAR mission team members at NASA's Jet Propulsion Laboratory, JPL, working with colleagues in India, executed the deployment of the satellite's radar antenna, Reflector, on August 15, 2025. The Reflector, which weighs about 142 pounds, features a cylindrical frame made of 123 composite struts and a gold-plated wire mesh. Its deployment involved a complex process called bloom, where the reflector unfurled by the release of tension stored in its flexible frame while stowed like an umbrella. The NISAR satellite carries the most sophisticated radar systems ever launched as part of a NASA mission, combining two synthetic aperture radar (SAR) systems, an L-band system that can see through clouds and forest canopy, and an S-band system that can see through clouds as well, but is more sensitive to light vegetation and moisture in snow. The reflector plays a key role for both systems, which is why its successful deployment is such a significant milestone. What makes the NISAR satellite truly unique is its ability to image Earth's surface down to pixels about 30 feet across, using SAR processing to simulate a traditional radar antenna that would have to be 12 miles long to achieve the same resolution. As Paul Rosen, NISAR's project scientist at JPL, explained, synthetic aperture radar, in principle, works like the lens of a camera, which focuses light to make a sharp image. The size of the lens, called the aperture, determines the sharpness of the image. Without SAR, spaceborne radars could generate data, but the resolution would be too rough to be useful. With SAR, NISAR will be able to generate high-resolution imagery. The NISAR satellite is the culmination of decades of space-based radar development at JPL, starting with the first Earth-observing SAR satellite, CSAT, which launched in 1978. The mission is a partnership between NASA and ISRO, spanning years of technical and programmatic collaboration. A successful launch and deployment of NISAR builds upon a strong heritage of cooperation between the United States and India in space. The data produced by NISAR's two radar systems will be a testament to what can be achieved when countries unite around a shared vision of innovation and discovery. And this is the part most people miss. The NISAR satellite has the potential to revolutionize our understanding of Earth's surface and its changes over time. But here's the question. How will the data from NISAR be used to inform decision-making and drive action on the ground? Will it be enough to mitigate the effects of natural disasters and climate change? The answer remains to be seen. But one thing is certain. The NISAR satellite is a groundbreaking mission that will have a lasting impact on our planet. To learn more about NISAR, visit https://ms.gov. Now, we want to hear from you. What do you think are the most significant implications of the NISAR satellite's mission? And how do you think its data will be used to drive positive change?